In this lesson, we will discuss displacement reactions as redox reactions. Displacement reactions involve reactions in which more reactive metals replace less reactive metals from the solution of their salt. This involves the transfer of electrons from the atoms or ions of one element to ions of the other. Therefore, displacement reactions are redox reactions.
Displacement reaction of iron and copper-2 sulfate solution. Procedure: place about 20 cm cubed of 1 molar copper-2 sulfate solution in a beaker. Step 2. Add 3 spatula full of iron filings as you start the solution.
When iron is placed in blue solution of copper-2 sulfate, the blue color fades to light green. Copper solid is deposited and is observed as brown solid deposit. The reaction is represented as follows. Iron is oxidized to iron 2, while copper-2 ions is reduced to copper metal. This implies that the displacement reaction is also a redox reaction. Redox reactions involve reduction reaction and oxidation reaction taking place simultaneously. From the displacement reaction, we can derive oxidation and reduction reactions. The oxidation reaction is: oxidation is loss of electrons. Iron loses 2 electrons to form iron 2 ions. The reduction is: reduction is gain of electrons. Copper-2 ions gain 2 electrons to form copper atoms. Displacement reactions are also found in halogens. Halogens displace each other from their respective salt solutions according to their reactivity. The following video clip shows displacement reactions in halogens.
So here I've got a solution of sodium iodide. Here I have some chlorine water. And I'm going to add now the chlorine water, which is, as you can see here, a colourless clear liquid. Going to add chlorine water to the iodide solution, the sodium iodide. Here we go. And you see there, certainly has gone dark. It's brown in colour. Dark brown coloured chemical has been formed. And this is iodine that has been displaced from the iodide solution by the chlorine in the chlorine water.
Potassium bromide solution is colorless solution. On bubbling chlorine gas, the solution turned orange in color. On the other hand, the colorless solution of potassium iodide turned black solid. Explanation: chlorine gas displaces bromide ions from solution to form orange solution. Chlorine gas displaces iodide ions from its solution to form a black solid. Considering the displacement reactions, chlorine gas oxidizes bromide ions to bromine water and it's also reduced to chloride ion. Chlorine gas also oxidizes iodine ions to iodine solid and is reduced to chloride ion. Chlorine is therefore an oxidizing agent, while the other ions, iodide and bromide, are reducing agents.